Assalamu alaikum wa rahmatullahi wa barakatuh. Good morning, everyone, and welcome to INHART webinar today about multivariate data analysis, principal component analysis to identify variable contribution. Our speaker today is Dr. Shirwan Sani. Dr. Shirwan is he obtained his PhD in halal product science at University Putra, Malaysia. He was also appointed as a registered chemist of Department of Chemistry, Ministry of Science, Technology and Innovation between 2006 and 2013. He is currently head of laboratory at INHART. So I think without further ado, I will invite Dr. Shirwan to begin the webinar for today. So Dr. Shirwan, the floor is yours.
Okay, Assalamualaikum warahmatullahi wabarakatuh. Okay, thank you, Dr. Amal, and thank you for INHART for conducting this webinar. So, okay, before I start, I would like to say thank you to everyone for joining us, and thank you to our FB viewers, live now. Okay, so I would like to share my PowerPoint. Is it okay, Dr. Amal? Can I proceed?
Yes, please, Dr. Shirwan, go on.
Okay. Okay, everyone. So I just stopped my video first. I just share with you my screen. Okay. So the title for today talk is about multivariate data analysis, principal component analysis, or we call it PCA, to identify variable contributions. Okay. So to all of you, previously when we start our study in bachelor degree, for example, and those class that we attended anything related to statistical subject, most of us that those subtopic that we learn is about, generally we do some t-test, ANOVA test. Even if you did your master's, your supervisor will love if you perform some statistical tests using ANOVA. So this is the principle of statistical analysis, and what you are going to learn to be introduced today is about multivariate data analysis, also part of statistical analysis. Okay, but I just want to remind all of you, this is an semi-advanced part. Okay, so when we start doing our t-test or our ANOVA previously, it is just a very basic one. Okay, but when we jump into this PCA, principal component analysis, so we are moving forward to semi-advanced. Okay, and if you go to advanced standing, you may encounter in the future, or currently now it's already booming, the application of machine learning, okay, or artificial intelligence. Okay, so this topic I just want to share with you. It's just some introduction because we only have limited time. So let's start. Okay, so those things that we the student will keep asking why we start to discuss about multivariate. Okay, so I told you in our previous years old studies, we use some statistical tests, these t-test and ANOVA. These t-test and ANOVA are related to one variable, okay, or in Malay we call it satu parameter, okay, one parameter or one variable. But when you have more than two, three and above, we call it multivariate. Okay, so more than more than two variables, so we call it multivariate. Okay, so when you have multiple variables, okay, for one sample, and you want to know the relationships among of the variable, this is where the multivariate data analysis jump in. Okay, So before we go into depth about multivariate data analysis, how about we see other aid? Yeah? Those aid that I referring here is about univariate and bivariate. Okay. How about univariate? So when you have one variable for your one sample, okay, and there are a few ways of analysis that you can do, okay, and the way also a few ways to display your result, okay. With one variable for one sample, you can have a frequency distribution table. You also can set up a bar chart, okay, and also a pie chart. So if you recall back what you have learned previously in your maybe high school and matriculation, or you have in bachelor degree, these are the frequent uh, way of displaying of your result, okay, by using this approach. And those tests that you can have, uh, t-test, ANOVA, Mann-Whitney test, Wilcoxon sign rank test. Okay, these are the applicable tests for univariate data. Okay, if you see here on this left side, okay, this is what I told you. On the you have one sample. Okay, this amino acid sample, and when I put it a B there, that B belong to one sample. We call it bovine. Okay, so this HYP is an example of amino acid. We call it the actual name is hydroxyproline. Okay, so one sample, one variable. The same goes this one amino acid. F is for fish. Okay, fish sample and one variable, which is hydroxyproline. Same goes with this one. Porcine, one sample and one variable. So this is an example that you frequently see when you involve with halal analysis. Okay, so this is about a univariate. Let's go to another one. A little bit deep about bivariate. When you have more than one variable, or and specifically you have two variable, we call it bivariate data. Okay, so there are common three tests that you can do to perform your analysis. The first one is Z test. Okay, so the Z test used to measure different mean between two groups. Okay, so you can see here, for example, this is your sample, and then you have uh, uh, first group. Okay, you analyze, you get the data, and then you another group you analyze again, and then you can compare the mean between these two groups using Z test. Okay, another test that you can do is chi-square test. Okay, this chi-square test, the aim of using it to check the presence of relationship between two variables. Okay, because we are talking about bivariate data, means two variables. You want to check if there is a existence of relationship between two variables. So in this example, for example, you have the sample and you have two data here, two variable here. So you want to check whether there is a relationship between these two variable. Okay, if we can go into deep a little bit detail, let's zoom to this one. Sorry. Okay, let's zoom to this one. So for example, I have one sample, porcine sample, and then I have hydroxyproline as one variable and histidine as another variable. I want to check whether hydroxyproline and histidine, both are amino acid, having a relationship among them or between them. So I perform a chi-square test. Okay, so you can see those tests that we perform, they have the hypothesis null, or null hypothesis, we call it HO, okay? And it also have hypothesis alternative or alternative hypothesis, okay? So if we go to see here, you can check. The H null is the hydroxyproline and histidine in the table are independent, which means they are not uh, having any relationship. Okay, so but when we perform a test, okay, the value that we get here is 0.05, and you can see the computations here state as the computed p-value is greater than 0.05, one cannot reject the null hypothesis. Okay, So the null hypothesis here is independent. So we cannot reject the null hypothesis, which means hydroxyproline and histidine are not having any relationship. So this is what a chi-square test can do for you. Okay. The last test that we can do, okay, this is an example. Okay, is a scatter plot. It's a scatter plot to check how strong the relationship. Okay, if we go to the the chi-square test enable you to check the presence, the existence of the variables, two variables. But if you want to check how strong the relationship, you go to regression and scatter plot, perform regression analysis, and check the correlation coefficients. So you can check the strong relationship between the two variables. Okay, for example, we have hydroxyproline again and histidine. You set up a scatter plot. You can use your Microsoft Excel. Okay, you can plot this one, and then you try to go to the trade line, try to get the equation and the R square. Okay, so this R square, we call it correlation coefficients. Yeah, and then to set up this R square, we call it a regression analysis. Okay, and then
Dr.
from
Shirwan,
here, yes.
Shirwan, some said that your voice is not clear. Can you maybe make it louder a bit? Thank you.
Okay.
All right.
Okay, so I just proceed now. When we perform the correlation coefficient analysis, we can get the value here is, for example, we have R square 0.136. Okay, since it's confirmed that hydroxyproline and histidine having a very weak relationship. Okay, it's support the result of the chi-square here, where the chi-square test say that there is no relationship. And then if there is a relationship, the relationship is very weak. Okay, that's why the R square value is 0.136. If you get a relationship near to 1, that indicate that the relationship between the variable is very strong. Okay, so this is what the test that we can do when dealing with bivariate data, or when we deal with two variables. Okay, and then again, we jump back to our main topic, why multivariate. Okay, so as we discussed earlier, when you have multiple variables, so in a specific connotation, if you have more than two variables, okay, for one sample, and then you want to know the relationship among the variables, you have to do some multivariate data analysis. Okay, what else this multivariate data analysis can help you? You can identify the sample grouping, and the last one, to identify the significant variables contributing to that grouping, and the last one, to predict the sample grouping. Okay, but for today's webinar, we only focus to this aims, which is to identify the sample grouping and to identify the significant variables that contribute to the sample grouping. This is what the principal component analysis will help you to analyze your data. Okay, so you can see here, instead of we have two variables, hydroxyproline and histidine. Okay, I add more than that. So in this example, we have 13 variables. So it's very good and very suitable to multivariate data analysis. Okay. So what the principal component analysis, or PCA, does to your multivariate data? Okay, this is your original data. Okay, and then the PCA will create a new uncorrelated data. We call it loading. So that's why you can see this example. We call it factor loading here. Okay, so you have 13 variables. PCA will perform some matrix calculation, and then they will create 13 uncorrelated data again. Okay, as if each variable having a individual column, individual data. Okay, and then PCA also will reduce the dimension of your data set and try to minimize the information loss in your data. Okay. So another way of display of PCA is this tree plot. Okay, the first one is variable plot. The second one is sample plot, and the last one is the biplot. Let's go to the variable plot first. Okay, so if you have a variable plot, those variable that you get here, for example, this one 13. Okay, so I just take this one. Out of those variable, they plot the variable using the factor loading. Okay, and then you can see this variable plot. Those variable which is near to each other are having a positive correlation. Okay, those variable which is opposite to each other are having a negative correlation. In this case, for example, we have MET, THR, SER, and histidine. Okay, these four is positively correlated. However, these four variables as well are having negative correlation to hydroxyproline. So this is how your PCA help you. Okay, and what else? Alanine and this one ALA and LYS. Okay, these and GLU, these three variables are positively correlated. Okay, another information that you can get here: if any variable which having equal to 90-degree location or direction, they are having no correlation or very correlation or minimal correlation between them. In this case, ALA, LYS, and GLU are having less or very weak correlation with MET, THR, SER, and HIS. These three as well having a very weak correlation with hydroxyproline. Okay, so this is how your PCA explain your data. Okay, instead of that, another plot that can be given to you when you perform your PCA, principal component analysis, you will get a sample. Okay, they will group your sample into the group that the PCA generate for you. In this case, PCA, we call it principal component analysis, is an unsupervised method where you don't tell the system you want how many grouping. So in this case, from your data, as I told you, this is a data about halal. Okay, so I have a P data, which is an information of a porcine data. This is a bovine data, denoted as B, and fish data denoted as F. Okay, so the PCA successfully group your sample into three groups. You have fish sample here, you have porcine sample here, and bovine sample here. So this is the grouping that the PCA generated for you. Okay, and if you superimpose the variable plot, and the sample plot, it will become a biplot on this left side. Okay, so you can see they take your variable plot here, they put into your sample plot to become a biplot. Okay, from here you can know that those variable, okay, it highlight it's with the red color is the variable which falls onto the sample plot. In this case, this fish indicate that this variable contribute to this grouping. So GLY, ARG, okay, MET, THR, SER, and HIS are contributing to fish sample. Okay, and then those variable like VAL, okay, PHE, okay, are contributing to porcine sample, and then hydroxyproline is contributing to a bovine sample. So this is what as I told you in the title, okay, how to know the contribution of variable to your sample. So this is the contribution that I told you as if in the title of this webinar. Okay, so now you know that if you have a MET, THR, SER and histidine, and also GLY, ARG. Okay, these amino acid, if you find out in your sample, unknown sample, you know that it falls, it may be from the origin of the fish sample. Okay, if you have hydroxyproline, it is highly possible from the origin of bovine sample. So this is how you explain the result of the PCA. Okay, but I think this example that I show to you is quite maybe you never know about amino acids. Okay, it's very new to you. How about if I explain to you using a real data, but the data that we know is quite common to us. Okay, so those data that I use in my class, okay, it's about food. Okay, so I have a McDonald's menu. I will stop this presentation first, and then I will go directly to my data set. Okay, so you have here in front of you is in the Excel sheet. Okay, so this is original data. This data is about a McDonald's menu. Okay, so you have a beef burger, cheeseburger, grilled chicken burger, hamburger, okay, fried chicken burger, beef patty burger, quarter pounder with cheese, fillet of fish, Pommes frites, apple pie, sundae chocolate, sundae strawberry, and sundae caramel. Okay, if you feel hungry after this, you can go to McDonald's. But we are going to discuss about the food composition. Okay, in this case, I perform in my lab an analysis about the energy of this sample, protein, and also carbohydrate, fat, and saturated fat of this sample. Okay, and then from this data, I would like to perform multivariate data analysis. Why? Okay, why I choose multivariate data analysis? Because it is more than two variable. So I want to check whether they have a correlation, okay, between the sample and the food composition and relationship among the food composition itself. Okay. So what I can do at the first place is, okay, you have to bear in mind when you have data. Currently now we are moving forward to big data. Okay, if you go to Google and anything related to economy, okay, business, they are looking forward to big data. Okay, so any kind of big data which is a very concentrated data, high amount, high velocity, and high variety of samples data, you need to perform some standardization or normalization. This normalization aims to make that your data are distributed normally or to make it mimicking to the actual population of your data. Okay, so you need to perform your standardization of the data. Okay, so I perform some standardized data analysis. Okay, so this is your actual sample. When you standardize your data, you will get amount or a number, or we call it a value, which is not actually the actual number or value for each of your McDonald's sample. Okay, so this value is referring to standardized data. Okay, and then I want to perform some PCA analysis. So what I can do, okay, I can perform here the principal component analysis. Okay, so I just click principal component analysis here from the software. We will talk about the software later. Okay, so here I just click the observation and variable tables. You just choose your parameter or variable starting from the label itself, and then you click variable label, tick that, and then for the observation level, tick that as well, and then choose the McDonald's sample down to the sundae caramel of the menu. Okay, please include the menu label as well. Okay, and then choose the option. Okay, in this analysis, I perform PCA type. I choose correlation for PSN because we are looking for the correlation among the sample and also among the variable. Okay. Click option. Okay, since this data, as I told you, you need to do some standardization. This data actually already, the software actually has this standardization method. So it's either you want to standardize or not. Later, you cannot avoid when you use this software. So this is already standardized. And then for this one, data option, click do not accept data. Okay. At the first place, you should make sure that your data, there is no missing data, no zero data in your sample. It's not zero. Some data which is not filled in your Excel cell, okay? But you have to ensure those data is there, okay? And then at the output, you just click valid sphericity test, case may all keen and the rest, okay? And on the charts, the important part, I want you to click choose type of biplot, click correlation biplot, okay? And then you click OK, and then you click continue, okay? So this one, before you click select and done, okay, you can see there is an information here. They say that they have two principal component, okay? Remember that we talked about the PCA here at the earlier stage, okay? So you have your original data and your PCA will create your another uncorrelated data, the factor loading, okay? So you can see there is F1 until F3, okay? So this is the F1 and F value that the Excel set, the software created for you. So in this case, they create two, F1 and F2, which is actually resemble to PC1 and PC2, okay? And then you can see here, the total percentage here is 75.99%, indicate that 75.99% of your data are explained in this study, okay? So you just click select and then you click done. Okay, so let's see about the data. So you can see the data itself. Select here, okay, starting from here, you can see the summary statistic. Okay, you have the energy, protein, carbohydrate, fat, and saturated fat. This is those food composition analysis. Okay, these are number of observation. Okay, missing values, is there any missing value there? No, because we already told you, make sure there is no missing value. Okay, okay, no missing value. Okay, and then the maximum value, the minimum value, the mean and standard deviation. Okay. The good thing about this software, they calculate for you as well the correlation matrix. We can check whether the food composition, food element, or the parameter are having correlation or not. Okay, you can check here. So you can see the energy and energy versus energy definitely is one, because the same parameter is having the correlation with itself, okay? But for energy and protein, the correlation metric is 0.1793, which is very low, okay? The principle of correlation metrics, those correlation metrics which is nearer to 1 indicate that you have a strong correlation, okay? And then, for example, we have here fat. You can see it's 0.8686, which indicate energy and fat are having a high correlation, meaning that if you eat more fat, you will get higher energy. Okay. Unfortunately, if you eat more saturated fat, you will have a low energy. That's why the correlation metric is very low, 0.1825. Okay. Let's go to those one that bold, which is indicate high correlation metrics. Okay. We have protein and carbohydrates. Okay. It has a correlation, strong correlation at 0.7245. However, there is a value here, negative value. Negative value means that there is an inverse correlation between this variable, which indicate if you have high protein, you will also have low carbohydrate, okay, in this study, okay? So same here, carbohydrate versus protein, the value is still the same, 0.7245, and fat versus energy, 0.8686. Okay, so this is the correlation matrix. Okay, when you perform the PCA using this software. I'm not so sure about other software, but this is the good thing that this software can help you. Okay, and then about the correlation between the variable, meaning that you have 5 variables, which are from food composition. You want to check, is there any correlation? Okay, so from this correlation metric is already proof to you that there is a correlation, especially energy versus fat, sorry, and protein versus carbohydrate. Okay, but in this Ballet's parity test, they will help you to support this correlation matrix by calculating is there any strong correlation. Okay, remember about the chi-square? Okay, the chi-square is used to try to find any relationship between two variables. Okay, so this is referring to the variables. When you get the result, you get the alpha value is 0.05. Okay, so you can see here there is no, the hash significantly different from 0 between the variable, but the hypothesis means there is a relationship between variable. Okay, it's already proven actually in your correlation matrix, but the Ballet's parity test, focusing on chi-square test, they will calculate for you. The value is of the alpha is 0.05, and then they make the calculation and the definition as the computed p-value is lower than 0.05, which is this one. Yeah, one should reject the null hypothesis. You should reject the null hypothesis. The null hypothesis say that there is no relationship between variable. Okay, so when you reject, you have to accept the alternative hypothesis. The alternative hypothesis, however, say that at least one of the correlation between the variable is significantly different from 0, which means there is indeed has a variable among them with a correlation, which is already proven here. Okay, so I just want to go directly to here, the way that we discuss. Okay, so this is the variable plot. Okay, you have the carbohydrate, energy, fat, saturated fat, and protein. Okay, remember when I told you, when you have a variable near to each other, in this case, for example, energy and fat, they are positively correlated. So you eat more fat, you will get high energy. However, those variable which is oppositely located, the distribution or the direction, these variable are having opposite or negative rate correlation. In this case, protein versus carbohydrate are negatively correlated, and then indicate that in this study, if that food has a high protein, it definitely has a low carbohydrate. Okay, let's go to another one. Okay, this observation plot, or we call it sample plot. Okay, the PCA plot your sample into grouping. Okay, so you can see those burgers are in this group. Those are the dessert here. Okay, those ice cream are in this grouping, and those another dessert like plum fries and apple pie are another location, another direction. Okay, and then you can see this is the meat sample, meat menu. But if you have a fish, it's a little bit uh, distance from the meat sample. So this is how your result is displayed in the sample plot. Okay, so when we try to get this one, we try to superimpose, we try to superimpose the variable plot onto the sample plot, you will get this bar plot. Okay, so let's explain about this one. You can see, okay, so you can see those burgers that you eat in your McDonald's, they are containing high protein, However, they are low with carbohydrates. Yeah, definitely carbohydrates are from sugar base. So definitely they don't put sugar in your burgers. Okay, so that's why your burger having a high protein. That's correct. Okay, but you can see here fillet of fish having a high energy and high fat. Okay, and that's mean of what? Okay, maybe because of the way of how they prepare the fillet of fish. Okay, they fry it, for example, or any sample preparation for the the way it's not sample preparation, the way that they cook the fillet. Okay, that cause the high fat and also high energy here. Okay, and then you can go to the opposite side. Okay, energy is high at this side, indicate that energy is low in this side. Okay, fat is high in this right side, indicate also fat is low in this left side. Okay, it make a conclusion in your sundae, caramel, sundae chocolate, sundae strawberry, your ice cream that you eat in your McDonald's, they are having a low energy and low fat. Okay, and low as well as saturated fat. Okay, however, if you can see your Pommes frites and apple pie, they have this group have a moderate of carbohydrate and energy because it's in the middle. Okay, so you can see that this is how the PCA helps you to identify your sample, to identify the contribution of your variable in your sample. Your variable is this 5 food composition and your sample is this menu. Okay, in the future, for example, if there is some fraud in the McDonald's menu, for example, or they're having their problem with their when they are preparing their food, maybe they accidentally put different ingredient. Okay, if they analyze these 5 food composition and rerun the analysis as again, they can check whether the composition of that menu is correct or correct or not. Okay, if it is incorrect, indicate that there is some problem during their preparation. So this is how the PCA as well can help the industries how to maintain their help their QC department. Okay, they want to ensure that the quality control of their menu is on par or on top as they stated in their documentation. Okay, so this is how the result of the PCA, principal component analysis. Okay, I think I can just go directly to this PowerPoint again. Okay, so if you have a further discussion you want to know, this is another example that I did in INHART. Okay, we perform halal fish feed analysis. Actually, this is a collaboration with University Putra Malaysia. Okay, so there is an issue of al-jalalah animal. Okay, where this animal is given the fish, for example, catfish is given with najis. Okay, and sometimes they are fed with the porcine or pig organs. Okay, so you can see here there is case in Batu Gajah, Trono, Papan Perak. Okay, this is published paper from one of our researchers in INHART. So from here we perform. There is an issue, big issue, published in Malaysia newspaper as well because of related to this jalala animal. Okay, this fish. Okay, and then we try to identify what are the variable that cause or that contribute or constitute from the porcine source. Okay, so we use the PCA, principal component analysis, and try to identify which element, which variable are contributing to lard source. Okay, in this case, we find out that there is 1, 2, 3, 4, 5. Okay, there is actually 4 or 5 triglycerides. Okay, in oil of the fish feed that indicate the contamination of or indicate that in the fish feed there is a mixture of lard ingredient. So this is how we help the researchers and as well as the government to identify whether those fish feed that developed in or they produce in Malaysia are having any porcine ingredients. Okay, and then there is another step to confirm this one, which is I not discuss. So we have, for example, we have here discriminant analysis, yeah, to support the PCA, principal component analysis. We also confirm the contamination of lard using this partial least square regression, okay, which is also not discussed here because it's very long and quite technical. So, and we all, at the end of it, we perform a Z test to confirm the one that we predict, okay, is correct, okay. And then to know better about this one, I would like to invite you to join my Google Classroom, Chemometrics in Data Analysis. This is one of my class, okay? So this is the class code. You can sign in into Google Classroom and then key in this class code and then you can get this information. This is the topic in the Google Classroom, okay? You can see I also have uploaded the way to perform PCA analysis using the SLStat, one of the software, okay? And before I end that one, I would like to talk about this software. Okay, this software, we call it SLStat, okay? Okay, so this is SLStat. Actually, it's just an Excel, but when you purchase this SLStat, they what we call the one, they attach this SLStat in your Excel software, and then you can get this very conclusive, is a high variability of different methods, okay, to perform data analysis, okay, including the machine learning that I told you, okay. So this is how the SLStat, and if you're a student, you just go on to click, you can download first for test, okay. You can download from this website, SLStat, try for 14 days, and you, if you are a student, you just purchase that one and then provide your matrix card, so they will give you a cheaper price, maybe like 200 ringgit per year, okay. So every year you need to purchase the license. It's yearly license. So this one is not like other software that you need to purchase the whole software, but this one is just you download the whole software, and with the license that they give to you, you can renew it every year, okay. So this is that. The good thing, because what I like about this one, because they just paste into your Excel. Compared to other software, they are also good, but sometimes you need to import. Okay, for example, you have SPSS, you need to import to your Excel, and or from your Excel, you need to import to the SPSS to perform the analysis. Okay, so this is about the software. And last but not least, I would like to also invite all of you, okay, to join our Halal Laboratory Workshop Series 3.0 Multivariate Data Analysis in Food Studies, okay, where we are going to conduct this one on 30th to 40th October 2020, okay, at INHART Halal Laboratory, IIUM Gombak. Although the title is focusing on food studies, but the application is very wide. You can go for environmental analysis using the same principle. In this workshop, it's not only focused to PCA. We can go to this cluster analysis, discriminant analysis, and multiple linear regression to help you in your research and as well in your work. Okay, and then you can register using this QR code. Okay, I think that's all from me. Thank you very much. And if you have any question, you can directly email me or text me. I think I prefer if you can go to email, or you can go to my Google Classroom, make a comment there, and then I will reply from that question from you. Okay, and that's all from me. I open for any question. And Dr. Amal, it's all yours now. I give it to you, the webinar to Dr. Amal. Okay, thank you very much.
Okay, thank you very much, Dr. Shirwan, for the very informative and really important sharing for today. I hope everyone can benefit from today's webinar, and mostly, inshallah, you will join the comprehensive one that Dr. Shirwan has shared right now, and you will find the data later on our Facebook as well. We have few questions, Dr. Shirwan. There is a question from Dr. Shibra. She's asking if there is any limit numbers of variable for multivariate analysis.
Okay, actually that depends on the software that you have. Okay, as far as I know, for the software that I recommend, the SLStat, the limit data is 10,000. So I think it's quite big, but some software like Unscrambler, they give a permission more than that. That's why it's very expensive compared to other software. So most of you have to check. You have to check with the software as well, the setting of the software.
Thank you, Dr.
Okay.
Shirwan. There is another question from Sister Noor Zafira, asking what is the minimum data required for a significant or meaningful multivariate data analysis, because it seems like small data will likely give high standard error.
Okay. Actually, let me show you about this one. Okay. Okay. I don't discuss this one actually in this webinar, but if you can see here, okay, you can see here there is okay, this one we call it Kayser-Meyer-Olkin measure of sampling adequacy, which means when you have a lot of data, okay, whether small or big, you can perform the PCA, and from the PCA it will give you the Kayser-Meyer-Olkin value. We call it KMO. Okay, so from this value, it will help you to say that if your sample is adequate or not adequate. Okay, so in this case, actually in this study, it's not adequate when the value is 0.2. If the value is more than 0.5, indicate your data is enough for multivariate data analysis. Okay, so there is some statistical part that you can check first before you perform any multivariate data analysis. This is what I learned from my colleague and from my friends. Previously, I also don't know about how much the minimum numbers. Okay, so when you see that your value is very low, it indicates your sample is not enough, and you need to make a more replication or take more samples, and then or increase number of variables. In this case, we have 5 variables. Maybe I have to analyze more data, more variables, and then to ensure and rerun again the KMO to get the value more than 0.5. So this is how another statistical analysis that can help the student to confirm whether their data is enough or not, or as a minimum number. Okay.
Thank you very much, Dr. Shirwan. I believe that multivariate data analysis will increase the quality of the data, so you can have more statistical analysis in your publication. I believe it will add quality to the papers. So go ahead and learn. Maybe you can try to rewatch this video later on our Facebook. And if you have further questions, you can email Dr. Shirwan. Follow our Facebook so you can know the exact date of our next training for multivariate analysis. I believe we have no further questions. So thank you all for joining our webinar today. Hope to see you soon in our next webinar, inshallah. Thank you very much, Dr. Shirwan, for the very good sharing session today.
Okay, thank you, Dr. Amal.
Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.